Hello and welcome. Hello and a warm welcome here to our Rust Linz meetup, the first meetup in the new year, 2023. It's January and it's not a Thursday today. That's a little bit different compared to other Rust Linz meetup appointments. Today we had to change a little bit because of a date conflict of Stefan, who will be with us in a few minutes. He will do a talk today. So we decided to simply switch our Rust Linz meetup this month to a Monday, and we hope that is okay for you. We are super glad that you are here, and we are super excited for having two awesome speakers. I will tell you a little bit about our program in a second. Let me quickly share my screen with you. I need a little bit of a setup here and start that one and share my screen. Here it is. So we will kick off the day with the evening with a round of community news. This is our 29th meetup. Wow, it has been a while. And next meetup will be our 30th anniversary. We are really looking forward to it. We are currently looking for additional speakers. We have something planned, but we still have one slot open. So if you want to do a talk at the Rust Linz meetup, don't forget to send us an email or just go to our website, rust-linz.at, and there you'll find the Sessionize link where you can always enter your talks if you want. And with that, let me tell you a little bit about our community news. As you all know, our meetup is brought to you by the Coding Club Linz. The Coding Club Linz is a community of passionate coders who come together, and they do free meetups and coding clubs for kids and things like that. That is what the Coding Club Linz is all about. Today's speakers, let's go right into the topic. The first speaker is Elliott. Elliot Frisch will kick off the day. You know that Rust Linz is a beginner-friendly meetup, so I think this will be a very interesting talk, especially for those of you who are not yet the perfect experts in Rust. Maybe you wonder, hey, what is this Turbofish syntax, this strange Turbofish syntax all about? Or what is this anyhow, and how does it relate to result and things like that? Elliot will give us a tour on topics like that, and we are really looking forward to his talk. Elliot's talk will be somewhere between 20 minutes, 25 minutes, something like this. And then our very own Stefan Baumgartner will do a second talk of the evening. Stefan will do a great talk about builder pattern and type state programming. So for his talk, this will kind of be the next level here in our today's meetup. So if you are designing APIs in Rust, I think this will be a very interesting one. We are looking forward to it, obviously. So if you would like to join the discussion, ask questions for our speakers and so on, you can always do so. Just join our Discord server. Here you see the link. I already pasted the link on in the YouTube channel. If you want, you can join us there. And if you ask questions there, I will take these questions and relay these questions to our speakers. You can also use the YouTube chat. If you would like to ask a question, feel free to use the YouTube chat, and our speakers will see it there, and I will discuss it at the end of their talks with the speakers. Now, let's dive right into the topic of community news. As always, we spend a little bit of time to introduce you to what's going on in the IT community around the Coding Club and in general around Rust and Linz and so on. The first thing, traditionally, is the note about our Coder Dojo Linz. For those of you who are new here at the Rust Linz meetup, Coder Dojo is one of our most important areas of work here at the Coding Club Linz. Coder Dojos exist all around the world, and we run Austria's largest and most active Coder Dojo here in Linz. It is a programming club, a volunteer-driven programming club for kids between 8 and 17. We start at the very basics with block programming, with Scratch, for instance, or Minecraft Education Edition and things like that, and we work our way up through web development, HTML, TypeScript, all this stuff, and even semi-professional software development for students, young students who study in some kind of technical schools. Our next meetings will be this Friday, and this Friday is something special. We have 2 different meetings. On the one hand side, we meet personally at the Tabakfabrik here in Linz. So if you would like to visit the Coder Dojo personally, if you live near Linz, for instance, come to us. That's the first workshop that we have. And the second series of workshops will be, as always, online workshops. So even if you don't live here in Linz, your kids, niece, nephews, whoever, they are more than welcome to join us here at the Coder Dojo Linz. We publish the program of Friday always on Wednesday. So take a look on the website here, linz.coderdojo.net on Wednesday, and you will see the workshop program for Friday. Everything is free. Everything is free of ads. It's completely volunteer driven. So we are looking forward to see you here. By the way, the Coder Dojo Linz is in German. So the children who join us there have to be able to speak and read German. The next one is our friends at Female Coders. Female Coders is a partner organization. We love to work with them. We have a long-standing relationship with the Female Coders Programming Club here in Linz. And their next study groups are in February. I think it's on the 8th of February. And if I can remember correctly, that will be a Vienna edition. So I think the Female Coders Linz will be guest at Female Coders Vienna. But please check out their website. It's female-coders AT, and there you find all the details. So if you are a girl or a woman who work in IT, in software development, or if you would like to get into software development and you are looking for like-minded women and girls who are already in this branch or who are also learning, then Female Coders is a great community. Next one is Technologieplauschel. Technologieplauschel is, I think, the largest meetup group that we have here in Linz. After a kind of COVID-related break, they are back. Now, a regular Technologieplauschel are going to happen again, and the next one is just in a few days. It's on the 26th of January, and that is exactly the reason why we shifted the Rust Linz meetup to Monday in this week. So, if you are interested in the Technologieplauschel, please check out their website. It will be an in-person event, so you can go to the Technologieplauschel and meet all your peers and friends in person. I would like to give a big shout out to Matthias, who will do a presentation at this week's Technologieplauschel. He will talk about from zero to production with Rust. You know Matthias, he is a regular speaker here at Rust Linz. He is a Rust hero, a local Rust hero who we are proud to have here. He did 2 talks about Rust here at Rust Linz, and he will do a talk at the Technologieplauschel, of course, also related to Rust. So this is a great meetup. You should definitely not miss that one. And last but not least, we got a promotion code from the Rust Nation UK. This is not really Linz and it's not really online, but still Stefan is in contact with the organizers of Rust Nation, and therefore he got a promotion code for -15% to rustnationuk.com. So if you want to go to this event and you would like to have 15% off of the price, then feel free to use this coupon code here. And that's it. That's our community news. That's all I wanted to show you. And with that, let's take a look. Is Elliot already here? Yes, we have Elliot already here. Let's get Elliot, our first guest speaker, onto the stage. Hello, Elliot.
Hello, Renier. Thank you so much for having me. It's very exciting to have this opportunity to speak with the Linz community, the wider Rust community. So I'm excited to share my talk. Today's talk is titled Anyhow Turbofish, and we are going to...
That sounds awesome. Thank you, Elliot. Let me also say thank you very much that you take the time to give us this talk. We really try to be a beginner-friendly Rust meetup, so I think that will be super interesting to have somebody like you. It's important for us to not always have these super deep dive stuff where only a few Rust experts can really benefit from it, but that we cover a broad range of topics. And I know from experience, I'm a trainer myself, that things like Turbofish are not so easy to understand for people who get right into the language. So we are really thankful to have you here. By the way, where are you broadcasting from?
Oh,
Where are you
excellent.
from?
Yes, I am located in Atlanta, Georgia, the United States, Southeast United States in Atlanta, Georgia. It's lovely here. It's very warm. Highly recommend it. And I'm also going to give as an introduction to this talk that I've been using Rust solidly for about 14 months now.
Okay.
And before that, or even concurrently with that, I have been a data engineer in my active life. And so when I first came to Rust, one of the very, very first things I wanted to do was what I typically do, which is read data from some REST API and use it to do something. Uh,
Mm-hmm.
the something is largely immaterial because a lot of time it's read the data from here and write it back out to there, or transform it, or do some math on it. But you know, it seems like that's a very, very frequent use case, and I wanted to start with that because that's what I did all the time. Using VS Code for Rust development and debugging, I'm going to go over that as well. Yeah, how to use the Turbofish and love anyhow.
That sounds great. That sounds great. Elliot, I'm going to share your slides now. And I think with that, it's time to get started. The stage is yours. We are looking forward to your talk. I will be in the backstage. So if you need me, just let me know. Otherwise, I will be back at the end of your talk to do a little bit of Q&A. I will relay all the questions from the audience to you, and we can have a nice little chat and discussion at the end. So enjoy it. Thank you for being part of the Rust Linz Meetup group, and the stage is yours.
Thank you again, Rainier. And thanks again for having me. So to start, or before I really get started, I did want to invite everyone to enter for a chance to win an Apple HomePod Mini. My employer, JFrog, is a platinum member of the Rust Foundation and would really like to give you a chance to enter and win the HomePod Mini. You can enter with the QR code or this jfrog.co link at the bottom, and I believe Rainier is going to put a banner on the video as well. A winner will be selected within 3 business days and will be contacted via email. I wish everyone the best of luck with the Apple HomePod Mini. Those are nice. So about me, my name is Elliot Frisch. At JFrog, our core competency is helping developers leap forward. I've been a developer for over 20 years and writing Rust code for a little over a year now. I have some links here to various information about me, as well as the code given in this talk, which can be found at the link at the bottom there to my GitHub. We'll start with the development environment. I've been using VS Code with the Rust language server and a number of plugins. This is fully documented in the README at the GitHub, but we can go over it real quick. There's some Rust language server, tab 9, fonts and turning on ligatures and things of that nature for a pleasant environment. And in my terminal, I use Oh My Z shell. And then, of course, I walk through how I've set everything up within this talk, including setting up a web server, various crates that I'm demoing. So to very, very start, we're going to start with a very, very simple JSON. In fact, the simplest JSON I could even think of, which is a very simple version string with a numerical value in it. So we're gonna parse this version string. So we've got a version, we've got some numerical value in it, and we're gonna use the JSON parse crate, and of course we need to match, because that could return an error on the handle, or it could be an OK. And if it's an OK, then we'll actually get a JSON value. We can then display whether we got that value or not. And I'm going to actually switch from here I'm going to share the VS Code now, so we can actually look at that code in practice. I have too many windows open. I apologize, folks. Why is this being so difficult right now? I'll just share my entire screen. I apologize. All right, so here's the exact same code, but now in VS Code so that we can just run it. So if we execute this code, you'll see that it parses out whatever version you put in here, and it doesn't matter if it's a string or not, because we are using a parse function and a JSON value. And so that's an enum type that can represent multiple things. And we are actually parsing it as a F32. So as long as it's an F32, we'll get that back out. And if it's not, then of course, we will get an error that it could not parse the empty string. So that is how that code functions. And we can then move on to a more sophisticated version and actually introduce anyhow, where instead of, let's go back to this first version. So in this first version where we're parsing it, there's quite a bit of logic that has to go into the matching conditions to determine whether it was a string, whether it was a number, whether it was a short, because again, this JSON value is an enumerated type. And when I was first starting out, this explicit matching seemed like it was excessively verbose. And so I spent a lot of time working on how I could reduce that. And the answer turned out to be anyhow, where we can, instead of matching on all of the error conditions, simply use anyhow to wrap them. And this will, instead of requiring us to match all of the various possible JSON values, we can simply say, attempt to parse it as a floating point, as a F32, a float 32. And if that fails, then wrap the whole thing in the anyhow error, and otherwise return an OK. So this significantly simplifies actually parsing our JSON. So if we go into the V2 and we change this to value and run it, it of course successfully parses it. And if we move the version and run it again, we'll get the same, can't parse an empty string. So far so good. Anyhow allowed us to eliminate a whole lot of boilerplate from version 1. So that was excellent. So now what can we do? Well, what if we actually went and got some JSON using a request blocking call? So this is going to use the HTTP request library. It's going to make a GET to a URL. It's going to get back the text of that, and then it's going to attempt to parse it. And the URL, it happens to be this, this string here. And so what I'm going to do, I can just start up a web server, and I have a version JSON in there. And now instead of parsing a simple static string, we're going to actually get that JSON and parse it directly. It's being a little slow, sorry. There we go. So we got a value of 3.15. Yeah.
Elliot, let me quickly interrupt you. I'm very sorry. We have a question from the audience. If you could increase the font size still a little bit, if that would be possible, that would be very nice. Very good. Thank you very much.
And let me just move this back over. I hope that's clearer for everyone. And just to remind everyone, this code is fully available in GitHub. It's also on the slides that have already been shared out. So yeah, I apologize if you still can't read it. I'll do my best to expand on it. So if we now go back over to edit that JSON in the v3 JSON folder, so we'll just bump the version here to something like 8.15. Why not? And now run it again. We'll see we get 8.15. So it is real code. It's actually making the HTTP request. It's getting back JSON and it's parsing it. So far so good. Well, what else could we do? Well, what if we made a call to an actual API out there? This is something called Zipopotamus, and it will return kind of like we were looking at before, where we get a floating point value as a string and then have to parse it. This actually returns floating point values as strings, and we have to parse them. So you know, we'll start with a default zip code. We'll make the request. We'll get a JSON response back. We'll match on that. If it was good, we'll try and parse it. So let's look at what that parse would do. We'll look for places. We'll get some geolocations out of it. We could actually use this geoutils location crate if we wanted to, but I don't see the need. Instead, I'm just going to build a Google map string based on the latitude and longitude based off of the zip code that we retrieve, so that we can then see it on a Google map. So that's a simple use case. So we can go into the v4 folder and run it, and I will give it the zip code of where I actually live, which is, like I said, Atlanta, suburb technically, but Atlanta. And we'll let it run. Make that big so you guys can see it again. And sure enough, we get back a latitude and longitude and a Google link. And if we open it, there's Atlanta, Georgia. Well, technically Norcross, Georgia, but there it is. And if we simply run the same thing, like I said, it has a default. So if we run it with the default, we get a very unusual location for a US zip code. This is the federated Micronesian island of Yap, which is in the middle of the Pacific Ocean. But it's got lovely beaches. So you can look at those. It's very nice. So we can move on to the last version that I've implemented here. And we could have several different URLs, and we could make all of these calls in parallel and iterate through them on success. So that's kind of what this code's doing. It's just kind of a reach, but it's making 3 different API calls in parallel and getting the results back and dumping them. So that was just kind of a stretch goal of what else could it do. And obviously, if we were to execute this, you'll see that it just prints the URLs, the statuses, and the text results pretty quickly. I will now go back to presenting the actual slides. So we can go through these. So again, now I'm going to really stop and ask if there are any questions. I'm currently working on Persia, which is an open source Rust-based service designed for securing the software supply chain. Everyone is welcome to join us. There's our main project website, and there's some more information about me. And then, of course, thank you again. And anybody, just a reminder, who wants to win that Apple HomePod Mini is welcome. With that, I'm going to turn it back over to Rainier and ask if there are any questions.
Hi, Elliot. Okay, thank you. Thank you very much. Let me quickly remove that one. Okay, that's fine. That was quick. That was quick. That was fast. That was a quick walkthrough. You closed your screen pretty quickly. Maybe you can reshare the Visual Studio, because we have some questions here from the audience who would like to know one or two things. The first thing let me share it here. Okay. The first thing that you didn't explicitly mention, but kind of raised people's interest, if you take a look at one of your methods where you have some condition that maybe fail, you have these question marks in your methods. Where you, for instance, parse the JSON. Can you elaborate on that a little bit, especially in conjunction with anyhow? What do these question mark here do, and maybe how do they relate to other programming languages, for instance?
I could certainly try. So anyhow is a library that extends the standard result and allows to wrap error handles into anyhow results instead of standard results. And the question mark specifically is anyhow allowing you to do that wrapping. So essentially this says if it succeeds, you return through the OK match, and if it fails, wrap the error in an anyhow error so that we don't have to handle it explicitly in the parsing function. So if we were to compare the very first version of my parsing code, it's significant, and I probably should have gone over this in a little more detail. But when you're matching the JSON result, which is a JSON value, it's an enum type. It could be a string, it could be a number, it could be a short, and it could be it could be something that it doesn't make any sense at all. It could be invalid JSON, right? So when you're attempting to match an enum type like that, you explicitly are going through all of these things saying, well, was it a number? Was it a short? Was it a string? And for each one, having to then say, okay, well, then I want to parse it and check to see if it succeeded. And so that's what all of this code is actually doing, is it's saying, okay, well, in any case, I just want to parse it and see if it was a F32. Well, you can shorten all of that. And that's what I was kind of trying to demonstrate by using anyhow. And instead of saying, I want to explicitly match all of the possible error or other conditions, simply assume it's going to work, and if it fails, wrap the failure condition and return that in a basic error. And so instead of having to write just all of that matching syntax, it becomes just a question mark at the end.
Okay, very nice. Very
and
nice.
that explicitly is anyhow. There's a related library for when you're actually writing libraries called this error by the same folks. So I should mention that as well.
Okay, got it. I think in your V3, or was it the V4, you even had two question marks in a single line, and I especially liked this example because it demonstrates how powerful this question mark thing is. Yeah, here we have it in line 24. Here you have two different situations where an error could happen, and you can simply write question mark in two places, and that demonstrates very nicely how elegant error handling can be using Rust. Don't you agree?
Very much so. And I appreciate you for calling that out, because yes, that is exactly the the direction I wanted to go with this, because again, when I first started, and I suspect when most folks first start with Rust, you start by saying, I'm going to explicitly handle everything.
Mm-hmm.
You know, whatever it throws at me, I'm going to handle it, because otherwise I'm going to get a compiler error. And those are awful, and I don't want to deal with that. And like I said, you end up writing what looks like a lot of boilerplate code, and then through learning and interacting with the Rust community, you start to evolve into these more effective patterns. And I think the anyhow pattern is a very effective one. So yes.
Got it. Got it. We have another question from the audience. We have this question. Let me see if this one. The question is, if you return an anyhow error, how can you handle the error? Can you write a match statement on top of your, for instance, get JSON to do some error handling on the caller side? So now the question relates to not the error inside of your parsing, but yeah, I think that is what was the topic. Yeah.
And indeed you can. So when you yeah, right here. When it gets the result, so we're assigning this version result from matching on the parse version. So it'll either be an error or it'll be a success. And so matching on that version result, if we succeeded, we'll get back an F32, which is a floating point 32-bit number. But if it failed for any reason, these are the anyhow errors as well, then we will enter into this error handling match right here. And that's where it would happen. Now, to actually get the underlying error, you certainly there are additional methods you can use to inject context into the anyhow error and this error as well. So if you actually need to manipulate the error message, you can do that as well.
From your experience, if people have now more detailed questions, they now saw anyhow and they want to learn more, is the anyhow documentation a good place to start?
Very much so. All of the Rust documentation, in my opinion, has been phenomenal, but the anyhow especially documentation is very good. In fact, if we were to go directly to the anyhow crate, it's not. We'll just Google it. Not mine. Okay, well, Google's trying to be very helpful. We'll click on it this way. It's down at the bottom. So if we go directly to this crate, you can see right here that one of the very first things they talk about is using the question mark to easily propagate any error that implements the error trait. So yes, I think their documentation is excellent. I would highly recommend people review it.
Okay, that sounds very interesting. One additional question is here on my list. You mentioned in your talk title the Turbofish. Can you show us the Turbofish?
Absolutely. Let's go straight back to here and let's look at right here. This is a Turbofish. Whoa. So we're doing a parse, and because we're doing a parse, it could return any number of different things, and the Rust compiler can actually infer the type in this circumstance probably, but I was explicit and I said I explicitly want a floating point 32-bit value, and this right here, the syntax : less than pipe greater than is a Turbofish. So yeah, that was kind of hidden there all along. Sorry about that.
No problem. That's perfectly fine. I think this is very important. I always see in trainings, when I do trainings in Rust, I see especially people coming from other languages struggle a little bit with this syntax, not being aware of the fact that in Rust, a method like parse does not, the name of the method does not include the type that is generated. It's not like in JavaScript where you say parse int, or like in C# where you say int.parse. In Rust, you just say parse. And in some cases, the Rust compiler simply doesn't know what should be the result, exactly like you just said. And then the Turbofish is very important because you can explicitly give a type annotation to the Rust compiler, and then it knows, okay, I have to call the F32 implementation of parse in order to generate an F32. And here the Turbofish is super interesting. By the way, Elliot, do you happen to know the website turbo.fish?
I do. And there's also a GitHub where you can download their source code.
Really? Maybe you can quickly open turbo.fish just so that everybody who maybe don't know this website just knows it, because now you see this, you will never forget it again. I was shown this website myself some time ago. I was astonished by it because it's so nice. Ihar is asking, so Turbofish is a type of a generic function. Let me show you the question here. Ihar, it's not the generic function here. In fact, the parse method comes from a trait, and there are many implementation of the parse methods for different traits. So you have a parse implementation for int32, you have a parse implementation for float32, you have a parse implementation for unsigned 32, and so on and so on. And by just calling the method, Rust cannot know which version of parse should be called. It's just a method that comes from a trait. So using the Turbofish is removing ambiguities, things that are not clear. I'm not sure if I'm using the right English word here. It clarifies to the compiler what it should do, that it should explicitly call the implementation of this parse method from this very type.
That is 100% correct, and the alternative would be you can be explicit on the left-hand side, and then it can infer it. So that's the alternative. So by explicitly saying I'm expecting a result that's an F32, I can omit the Turbofish, or I can explicitly include it in the parse method call. So either one.
We have another question here that is now a follow-up question. What trait does my script should implement in order to be able to be used with parse? Do you want to give the answer, Elliot, or should I?
Sure. I believe the answer is the from string.
Exactly, it's
trait.
a Fromster. It's the Fromster trait. The Fromster trait, uppercase F of uppercase S, has to be implemented, and that's implicitly used behind the scenes if you use the parse method of stir. Yeah, exactly. Yeah, very good questions. Thank you very much. Okay. Did we forget anything? Are there any other things that that you would like to tell our listeners? I think it was a very interesting talk. Thank you very much.
Thank you so much for having me. I think we covered everything I wanted to cover, but obviously I wanted to make sure to leave time if there are any other questions. So if there are no other questions, then I will yield the floor back. But again, thank you so much for having me. It has been a genuine pleasure. I look forward to the rest of the speakers.
Very nice. Thank you very much, Elliot. No, I don't think I have any further questions right now. Just one question. Will you be able to share your slides and the code with us? I think you do, right? Will you post it yourself on our Discord server, or should I do that for you?
If you wouldn't mind doing that for me, just so everybody can find it.
But that is no problem. You already sent me the slides, so I will share the slide deck, and now everybody knows it. If you are interested in the code that Elliot showed us today, and you would like to dive in yourself in these code samples, then you can do exactly that by taking a look at the presentations and the links which are embedded in Elliot's presentation.
And feel free to fork the repo.
Thank you very much. Thank you, Elliot. Thank you for being with us, and thank you for sharing your presentation. I wish you a very nice day. Is it day? Is it morning for you? What is the time?
It's afternoon. But
it's afternoon. Okay, it's evening for us here, so enjoy the rest of the day. Thank you very much for being with us at Rust Linz. Bye. So this was our first speaker, and now we have our second speaker. And
hi.
Hi, Stefan. I don't think I
Hi.
need to ask you, where are you broadcasting from? Because
Yeah,
it's just a few meters
close
away.
to you.
Exactly. Hey, awesome that you take the time and you took the time to prepare
Sure.
another presentation to give it here at the Rust Linz meetup. I think you were really looking forward to giving this presentation here at Rust Linz. I remember you talking multiple times about, hey, when do we have the time? Because I think this is a topic that is very near to your heart, isn't it?
Yeah, so it's a fun topic. I already have written about it at one occasion, and it's one that when I do workshops, etc., it's always a nice example to pull out and present to somebody who is not so familiar with the powers of a type system. So it's it's kind of my thing to talk about type systems, to talk about fun things that you can do with types, and that's why I'm really excited to talk about this. But excitement to talk about this and time to prepare everything, those are usually two very different things. So I'm really curious how it will turn out. It's for the first time. I've prepared a lot of examples, a couple of slides. And I hope everything goes as smooth as I've planned it. So yeah, let's see.
Oh, I'm very sure. I'm very sure. Should I do the presentation on StreamYard for you, or will you handle everything on your
I
own?
just shared my slides, so you can pull it up. So that's cool.
Okay, very good.
And I hope you can hear me all right. So not only do I have new slides, new examples, I'm also trying out the new editor today, having a new light, a new camera, a new microphone. So everything's new. Everything can fail. So if anything goes wrong, it will be most likely everything. So let's see how this turns out.
Let's not hope for Murphy's Law,
Yeah.
right?
No, absolutely. But that's the pleasure of having a meetup. Meetups, I see meetups always as a stage to try out new things. And
Absolutely.
so yeah, that's why you are all guinea pigs today for me.
Yeah, we love to be. Okay, Stefan, the stage is yours. We are looking forward to your talk.
Okay, thank you very much, Rainer. All right, so hi, I'm Stefan, and I will talk to you today about the builder pattern and type state programming. And before I start, maybe let me look real quick. So before I start, I want to ask you if you recognize this image. It's called Swans. It's from 1956. It's from MC Escher, who is a very known artist, and I love his name or their name because I guess MC are the initials, but I always think of a techno club's master of ceremony when I read this name. So this image, those swans flying in a pattern, also produced on some sort of pattern, is the cover image of the book called Design Patterns, Elements of Reusable Object-Oriented Software, by the eponymous Gang of Four. So it's right here. I hope you can see it. And this book is now almost 30 years old. So it has been published for the first time in 1994. It has possibly sold over 500,000 copies because it has really defined how people think of object-oriented programming. Short disclaimer, I learned about object-oriented programming, of course, in university. I have done my fair share of object-oriented programming in the past. I wouldn't tell from myself that I'm an expert in object-oriented programming, but this is all part of this talk because I decided to look at traditional object-oriented programming and see how it holds up in Rust. And those design patterns, this design patterns book defined 23 classic software design patterns with examples in C++ and Smalltalk. And university teachers all over the globe rejoiced because they finally have enough to put on their slides for their curriculum. This is where I learned it. So I learned it at the Linz University, Software Engineering 2, Object-Oriented Programming, and we did all of them in detail, but in a Java context though. The book splits up design patterns in 3 categories. So first, there are creational design patterns. They center around the creation of objects rather than instantiating objects directly. There are structural design patterns. They are concerned about class and object composition. And last but not least, there are behavioral design patterns, which define communication between objects. There's one behavioral design pattern that you should know when you're developing Rust, which is the iterator. So iterator is a classical design pattern, and here you can see how they hold up in Rust. It's also worth noting that the Gang of Four, the four authors, Erich Gamma, Richard Helm, Ralph Johnson, and John Lycides, I hope I didn't butcher his name, that they claim that they have not invented design patterns, that they are not a new concept, and they were present in software development for ages, but they were the first ones to collect them, to talk about them, to give them names, so people have a common vocabulary for discussing design patterns. And this is why this book is also so impactful, in my opinion, because not only has it described lots of common things in software development, but people were able to talk about it. And I guess this is why, to this day, this book is one of those which is still recommended, even though, it's the way it's written is I guess you wouldn't write a book like this today, but you can still get a lot out of it. And again, I tried to see how do they hold up in a modern day programming language like Rust. This is a little side project of mine, which I call Gamma's Radiation. Gamma because of Erich Gamma, one of the authors of the book, and the radiation, like, okay, if his ideas radiate to this time, how far do they radiate? So it's a little play on words. And how can those patterns be developed in Rust? You know that Rust has many influences from other programming languages like C++, also influences from other object-oriented programming languages as well. And the Rust book, this one here, I have it here as well, the Rust programming language, which is the paper copy of the one book that you find online, also discusses object-oriented programming. And the funny thing is, it discusses it with a quote from the design patterns book. So this is now a quoteception, because this quote here is quoted from the Rust programming language, which quotes it from the design patterns book in a talk about design patterns. And it says that this book, that object-oriented programs are made up of objects, yes, okay, and an object packages both data and the procedures that can operate on that data. And the procedures are typically called methods or operations. And well, we have that in Rust. If you boil down object-oriented programming to that, we have structs and enums and we have impl blocks. So yeah, with that, we have some way of object orientation. It might be a little bit different than you know it from, well, languages like Java, because Rust lacks inheritance, and inheritance is a fundamental concept in Java. And you also, if you think about implementing objects against an interface, yeah, you can do that with traits, but you also need to define the relationship of a trait, like to memory. Like, is it just some marker for monomorphizations over traits through generics, or are you using trait objects, which is a fundamentally different thing in two fundamentally different programming styles? So yeah, we have object orientation, which means it's good to revisit those old patterns of object-oriented programming. And one pattern that I decided to start with, well, next to the iterator pattern, obviously, is the builder pattern, because this is one pattern that I constantly stumbled upon. So I've seen that in libraries, I've seen that in the standard library, and I've implemented a couple of builders on my own as well. It's a creational pattern, and if you do it right, it's also a recreational pattern. And it's in chapter 3 of the book, the first chapter of the design patterns catalog, and it's the second pattern already. So it's pretty early in the book. And the builder pattern is for object creation. It's a creational pattern, and it says that you should use it when the algorithm for creating a complex object should be independent of the parts that make up the object and how they are assembled. And we are going to see a couple of examples for that. And also the construction process must allow different representations for the objects that's constructed. Well, this is, a little bit about polymorphism, and we are not going to touch that. We are only talking about the creation part, about the assembling part. And, since it's a book that it's loved by university, we have class diagrams in there. So this is something where you can fill up your slides like I do right now. And you have a couple of different components in this builder pattern. So first of all, the builder. And the builder is, in this case, an interface. So if I remember correctly from my days back in university, if it's italic, then it's just an abstraction, not a concretization. And the builder specifies an abstract interface for creating parts of a product object. Then here we have a concrete builder, which is an implementation of builder. And it actually constructs and assembles parts of the product by implementing the builder interface. So it defines and keeps track of the representation it creates. but it also provides an interface or a method for retrieving the product. So this is get result in that case. And of course, then you have the product. The product represents the complex object, which is under construction, and the concrete builder builds the product's internal representation and also defines the process by which it is assembled. And last but not least, you have the directory, because everything needs to be an object. Well, what it does, it calls the builder and it assembles parts. So you can say build part that, build part this, yada, yada, yada. Let's see how it works in Rust. So in Rust, you are stumbling upon builder patterns if you look, for example, at Hyper. So Hyper is the crate for doing HTTP requests and responses. You can implement clients with it, servers with it. If you have done anything web-related in Rust, you have used Hyper in one way or another. And Hyper has a wonderful way of constructing requests. And in terms of a request, it makes a lot of sense. We're going to see why. And this implements the builder pattern. We create the builder by calling request : builder. It gives us an instance of the request builder. And then we have a fluent interface where we can specify different parts of the product, which is a request. We want to get the request out of that. So we have one method to define, well, the method, get, post, put, delete, whatever. We can define the URI, we can define a header, and we can add more headers. This is a funny thing about builders, because we can say, well, I don't know how many headers I'm going to have. Why would I need to specify everything upon construction? I have them stored in some variable, in some binding. Let's move them over to the builder. And this is a very flexible part. But in the terms of an HTTP request, this makes a lot of sense. You don't know how many headers you are going to set if you deal with dynamic requests, for example. And also here, the last thing, and this is beautiful, after we have defined everything, we call builder.body, which gives us the product. And the product is the finished HTTP request. And the body method call is the last method call we do. So after that, our object is constructed. And this follows, the pattern of an HTTP request. We are defining method in URI, then we're defining a lot of headers, and the last thing we define is the body. And in theory, up until that point, Hyper could think of, well, maybe we're already sending the first information like get, URI, header, and only when the body is being set, we are closing the request. So you can do a streaming HTTP request, and the way this interface is constructed, it allows you to stream on right away. So this is a nice nuance. I don't know if they do it like that, but the interface would allow it. So every step is concrete. And if you think about all the variants an HTTP request can take and all the variations that you can do, having an interface like that is beautiful. And this leads me to a couple of implications. So first, setting headers can be either very easy or very complicated, but the interface of the builder is prepared for both. And in this example, I did set an HTTP method, but I don't have to, because there's a default HTTP method, which is get. So I don't need to define an HTTP method. So I also have the possibility to default on a couple of values for the properties that I set. And then if you think about having all this complexity, and you think about how Rust defines function interfaces and methods, Rust has no variadic argument lists for functions. Think about println. Println is not a function, it's a macro. Why? Because we have a variadic list of arguments. And you can't set default values for function arguments. So if you use a constructor function like : new, which is, funny enough, a pattern on its own, it wouldn't work as well. And we can see that in this fictional representation of a standard process command. So this is not true. This is something that I put up. A command exists in standard process. It is used to spawn a child process where you can set the command, some arguments, environment variables. You define standard in, standard out, and standard error. And you can have a working directory. And the working directory is, funnily enough, the only thing that is optional. Every other thing, all the other things need to be set. And if I'm doing a standard constructor function where I'm going to set all those values, you see on the right-hand side, this is the new function, and everything is optional except the one thing that I actually need, the one thing that I actually care about. And in my implementation, I either say unwrap or default, or I set it to IO standard in, IO standard out, IO standard error. So I'm setting already a couple of default values. And this constructor function is really, really inflexible. If I look at the usage, look at that. So I have ls.into, then maybe L and A as arguments, and then lots of none. And I don't even know what all those nones mean. So this is something where I say, well, this is a really, really bad interface to use for something like a command, for something that spawns a child process. I mean, I could instantiate it directly, like having the struct open and set command to ls, and then just go for default. If I implement the default trait for command, I can do things like that. But then again, you would need to know a lot about all those properties. And the more complex the object or the instance is, the harder it gets to say, well, just to default. And maybe you really want to know what's behind it, or you want to have a little bit of flexibility. If we look at the actual implementation from standard process, well, they use a builder. Command becomes a builder by say new ls, so list everything with the argument L, with the argument A, and then spawn the process. Cool. That's a one-liner. It's beautiful. And when you read it, you know exactly what it's doing. And if you have something more complex, well, for like the optional working directory, you can say, well, let's do a new command. Let's set a couple of arguments. And then if I have a working directory, well, then please set it and then spawn the command. So again, also from the construction here again, it becomes obvious what it does, and it's prepared. The interface is prepared for everything. A really, really beautiful interface. And something, I get pretty excited about interfaces like that. If I look at this example from the docs, so I can say either I do something on Windows, it's not PowerShell, I guess it's just command, where I have a couple of arguments, or I call it on Bash, I can decide it in an if condition, whatever. But the beautiful thing here is actually the output. So I'm creating a different kind of object once I call output. I don't call spawn, because spawn just spawns a process, but I don't know anything if I want to get the output or not. And with .output, it executes it and waits until it gets some output, which I can read then afterwards. And I love those kind of things because it's a really, really nice API. I can basically construct my command entirely and then decide if I call output, if I call build or spawn, depending on the context where I am. And this is also a flexibility that I get from a builder pattern. Okay, a little bit more about builder patterns in Rust, because, this is something from the standard libraries, something from Hyper, but there are lots more builder patterns in Rust. And usually we differentiate between two variations. One variation is a non-consuming builder. And a non-consuming builder is respective to the ownership of the builder structs. So command is a non-consuming builder. If I look at the implementation, this is abbreviated because it has much more, or many more methods. I have a struct command. The impl block creates a new command, and with every arg or args that I add, I'm adding something to the list. And if you look at that, both arg and args and also all the other methods there use a mutable reference to itself, which means that the actual instance is going to be changed. And to get a fluent interface, so you can call .arg, it also returns a mutable reference to itself, which means that if you call .arg, if you call .env, it changes the actual instance, and so on and so forth. And this is non-consuming. You don't consume the actual instance. You are changing the instance. And this has a couple of implications. So if I call it, for example, like that, I say let command is command : new with one argument, the return type is not command anymore, it's mutable command. So it's a mutable reference to command. And if I call spawn in the next line, I'm getting an error message because, well, I don't have an owner. So if I call command new .arg, I don't have an owner. The owner is transient. And if I have a borrow later on, it doesn't know what the owner was or what the owner is. And the Rust error message is actually quite nice. Thanks, Esteban, by the way, because it tells you what the problem is. And it also tells you how to solve it. Create the new builder, store it in the binding, and then do all the other changes. So you wouldn't need to assign it then again to binding.arg, assign it to command. But you need to have the first instance. Once you create it with new, you need to store it in a binding to continue with it. And of course, you can still do one-liners. So one-liners are still totally fine. On the other hand, you have consuming builders. And this is also an example from standard thread builder. So you can create a new builder, a new thread via this builder, where you set the name, an optional name, and can set the stack size. But if you look at the interface, this is also abbreviated again to fit on a slide. You see that they take a mutable owned struct. So not a mutable reference, but an owned struct, and also return an owned struct, which means that if you are changing methods within your control flow, you need to reassign to a new binding after each method call. One-liners or chained methods still work as well, but if I would call here thread.stackSize without an assignment, thread would drop. So it would not change the actual instance. It would produce a new instance, and the original instance would be dropped. So yeah, one-liners to an extent still work, and those are the two different kinds. Usually, the Rust style guide says that non-consuming builders are preferred, and you really need to have a reason for consuming builders. So, and this leads me to the second half of my talk, types deprogramming. We now have seen what the builder actually is, and now I want to play a little bit with interfaces. Builders have an actual use cases in Rust. We've seen that good use cases as that. But I want to know if it's easier or if I can steer in some way how my products are constructed. And it should be simple to my users, and it should be elegant, and it should be fun. And what I want to create is, again, it's always my example. Maybe I'm biased here, but I want to create a serverless platform. And this serverless platform creates execution environments where you have a worker or a worker process that contains the workload, the one thing that you want to execute, some allocated memory, and a flag if the worker should be kept alive after execution or should be terminated. So, this is the typical cold start in serverless where you say, well, I boot something up, and then please keep the instance because I want to send the same workload over and over again, or I want to use the same parameters. And, to execute everything, to spawn a new worker or to build a new worker, you need to have all properties set. You need the workload, you need the mem size, and you need keep alive. However, only mem size and keep alive can be pre-filled with defaults. You have some default settings and you can change them later on, whatever. But they are defaults, the workload isn't. And the workload might come from an external source, so you don't know when constructing the instance if you already have a workload ready, or if the workload comes from some stream or some request or whatever. And this nuance is mirrored in the worker builder. If you look at the worker builder, it has the same properties as the worker, but it contains an option of a string. So the workload is not yet defined. Either we have a workload or we have no workload. And this is, by the way, also a great usage of a worker because, you are assembling parts, you're constructing things with a builder. And if you don't know about certain things yet, well, then you have an undefined value, or you have a nullish value in other programming languages. In Rust, you have the option to a value. And you can make sure that only if the workload is set, that you have an actual worker at hand that has everything it needs. So the builder is a great way to get rid of those optionals if you don't need them. So yeah, a little bit of a different API, and that has some reason. So now let's implement a very rough implementation of a worker builder. So first of all, we have the worker builder up here. We're creating a constructor function. It has no arguments. So we say workload. There's no workload. We don't have one defined yet. We create the memory size. This is, well, in megabyte, I guess, 128 megabytes. And we don't want to keep it alive. So the worker is terminated after execution. And then we have the workload method. So this is where we set the workload method. It's a mutable reference to myself, which means it's a non-consuming builder. And workload impels into string, which means that anything that can be converted into a string, I take it. This is a beautiful way of monomorphization, beautiful way of working with generics, where I just say, well, give me whatever you have. Can be a string slice, can be an own string, can be anything that implements toString or display. Doesn't matter. As long as you can be transformed into a string, I'll take it. And then I said, well, I set the workload to this workload. I call workload.into to go from what it had to an actual string, and it return myself. This is how I get this chainable interface. I dropped the methods for memsize and keepAlive. They're pretty easy. We're going to see them later anyway. Okay, so this is how I set my workload. And then I have here the build function where I say, well, I create the worker and it has the workload. I call unwrap because, hey, I'm sure that workload has been set. I transfer memsize, I transfer keepAlive and have this worker. And actually, this should be just self or a consuming method, because after this step, I want to consume the worker builder, so the worker builder can't be reused again. After the worker builder terminates, I want to be done with it. So this is an error in my slides. I'm very sorry about that. But here's one problem. So I have this scared emoji right next to it because, hey, I'm calling unwrap here. This is an unsafe operation. This might panic. If I didn't set workload, everything might go boom. And I want to avoid that. And I want to avoid that. Well, I have a couple of possibilities there. First, I could just say, well, you're not getting a worker, you're getting the result of a worker or maybe a construction error. Result types work beautiful in that. And you have transformation methods from an option to an error and back would be a beautiful way to develop. But, well, actually, why would I even allow to call build if I don't have a workload set? And I can implement that stuff. I can implement that through type state. Let's see how I do it. First, I change the worker builder interface. So I say the worker builder now doesn't have a workload, which is an option of string, but it has a generic parameter. It has a generic parameter where I have not decided yet what the workload should be. And then I'm going to implement the generic worker builder. Those are all the methods which don't care about the state of my workload, because the workload has a state. Either it's here already or it isn't. But those methods for memsize and keepAlive, they don't care about the state of the workload. So I can implement that for the generic version of worker builder. And this is what I do here. So it just settles. You have implemented that. And again, it takes a mutable reference, returns a mutable reference. So it's a non-consuming builder. But now I start with the case, what if I don't have a workload yet? And I define a struct no workload. Look at that. It's an empty struct. It has no fields. It's just here to say, well, this is one thing I want to care about. And then I implement worker builder for this particular struct. So no generics anymore, just for this particular struct. And here, in this particular implementation for worker builder of no workload, I have the constructor function. And the constructor function says new, it returns workload, which is no workload. It fits because, hey, that's my parameter here. That's okay. The memsize and the keepAlive. Fine, that's great. And I already defined memsize, I already defined keepAlive. So now I need to define workload. And it takes again a workload impl into string, but look at that now. I'm not returning self or changed something in my parameters. I'm returning a new worker builder. I'm returning a new worker builder where I set the workload into, well, this particular string, where I set the memsize to self memsize, keepAlive to self keepAlive. I'm moving those fields over to the new worker builder. And if you look at the function signature, if you look at the return type, I'm now not returning self. I'm returning a worker builder of string. So I'm having the same struct, the same type, but I have a different state of my generic type. So I'm moving from no workload to string. And you can really think about it like a state machine. So you start at no workload, and when you call workload, you're moving to a different state. So let's implement the rest. Let's implement worker builder of string. Here I have the build method. And again, sorry, this is wrong. This shouldn't be an ampersand mute. This should be just self. And this one, since now I'm 100% sure that I have everything that I need, that I have a workload, I can simply construct a worker with the workload, with memsize and keepAlive, and return that. And yeah, that's the last state. And the beautiful thing about that, workload has a different state. Workload has a state where it starts, which is no workload, and then it has a state when it ends, which is I'm having a workload of type string. And those are two bookends of the construction process. So this is where you start in the builder pattern, you start creating your builder, and then you are done with the building process and you're getting an actual object or an actual instance of your struct. And those two bookends are always there in a builder pattern. And the one thing in the middle is variable. This is the one thing where something changes. And those two bookends are separated by state by the different implementation blocks. So it becomes totally obvious which state should be the start, which one should be the end. And you know what? I do think I have some time left. Let me quickly switch my screen to. There we go. Yeah. So actually, now I just had a talk and I'm doing some slides. Now it's getting really interesting because I'm doing NeoVim and I haven't done it yet. Oh, sorry, I should add it to the stream. Damn it. So it's going to be interesting. I hope I don't. I'm not stumbling over myself here. But here I've implemented everything you've just seen. Here I have the worker, I have the struct no workload, I have this worker builder of W. I have the implementation for the no workload state, and I'm having here the worker builder of string, where I'm actually getting the build method. So yeah, here I've also changed something. So here I've also changed it to a consuming call because I'm getting a new struct. So this is okay. This works like intended. And here I'm having mem size and keep alive. So there you go. And now let's try to implement it or to work with it. So I'm having my worker, and I say worker builder. Yeah, okay, new editor, colon, new, there it is, works fantastic. And if I look at it, I'm getting a worker builder of no workload. So the inlay hints from Rust Analyzer already tell me that I'm having no workload. And I can do things like, whoop. Working with a new editor for the first time. It's ridiculous. There we go. So I can do things like set mem size and set or keep alive to true, and here setting mem size to 256 times this one here, and if I save it, there you go. And so I'm still having you don't see it that well. Let's add keep alive again. So Rust Analyzer formats to something nice. There you go. You see that I'm having here a worker builder of no workload still. So nothing changes here. It's still a worker builder of no workload. But if I'm going to change this to build, look at that. I'm also getting the notice, well, no method name build found for struct worker builder. So it's not there. It's not within the implementation that I have here. And if I do cargo build, it also tells me method not found in worker builder no workload, but the method was found for worker builder string. So again, thanks Esteban, those are great error messages that help me with my case. So I go to this line and say, well, now I'm setting a workload. And I'm setting it to an empty string. And look at that. Now it changes from worker builder no workload to worker builder string. And now I'm also having the build method available. And now I'm getting a worker. So this is what I get out of that. And I still can work with those generic methods. I still can say, well, let's have mem size and set it to something entirely different. Or let's call keep alive and change it to false. So I'm still having those methods that come from the generic implementation. They are still there because they're generic over all possible states. But the moment I add a workload, I'm moving state from the concretization of no workload to the concretization of string. And this is how I can use type state programming to make sure my APIs are good, to make sure that when I develop something, that my users and everybody who uses my APIs are not doing anything wrong. And I don't have any weird states where I need to take care about results when the only thing that can happen is to have a workload in the end. So if my API tells me that I need to have a workload, then I need this pattern or this way of constructing objects is really, really nice and helps me a lot in the way I work. Okay, back to my slides. Just 1 second. And boom, boom, boom. Here I go. So yeah, okay, you should see my slides again. There you go. Okay, I showed it. That's fine. Little summary. So how far went Gamma's radiation? Yet I guess the builder pattern holds up really well. In fact, I think it's perfectly suited for us. So it shows with a lot of examples that we've already seen in Hyper or in the standard library. And if you have situations where you're constructing a complex object that may react to certain things in your program, then well, it's really good to use a builder pattern if you want to construct something. The pros are it's suitable for one-liners, so for easy construction, but also for complex construction. It prevents proliferation of constructors, which means, well, what if your constructor takes, then I don't know how many function arguments or methods function arguments. How often do you need to set an option, even though you shouldn't? If the constructor gets more complex than instantiating it directly, then why not using then why don't you use a builder directly? It hides the complexity of the product, and with TypeState, it can add a fantastic and type-safe API. The cons are, well, constructor functions or direct construction are simpler in design. They might be more accessible in the beginning, but well, if you have simple objects or simple structs, then a builder pattern is obviously overkill. And with that, I'm at the end of my talk, and I'm open for all the questions and say thank you very much.
Thank you very much. Thank you very much, Stefan. I so much enjoyed your talk. I have my dinner here in front of me. I was eating great pasta, watching a talk about Rust and the builder pattern, and I very much enjoyed it.
Thank you, Rainer. I'm so hungry. If you're talking about pasta right now, I can hear my stomach growl.
I was able to cook my own pasta and eat half of it during your talk. So,
oh, damn! Sorry. I should have talked longer then.
Yes, you should.
Finish it.
No, just kidding. Stefan, we have a bunch of questions. First, people were saying, very cool stuff. So I think you did a great job.
Thank you very much.
I have to start with a question. Why NeoVim? Why no longer Visual Code? If nobody else is going to ask this question, I will. Just out of curiosity, or is there a deeper meaning?
I call it my midlife crisis now.
No,
the thing is, I set out trying out new editors over Christmas, actually, because I'm currently writing a book, and I found Visual Studio Code with this particular book project to be really, really slow. So I had the urge to try out something new, and I tried Sublime Text again, which is nice, and I also tried NeoVim, so something that optimizes for speed. But as you can see, I'm so clumsy with it, with the Vim bindings. I'm much more productive in Sublime Text, though. But I say, well, if I don't try it, I can't argue about it. So this is why I tried it out. Yeah.
Okay, very nice, very nice. Okay, so now to your to serious questions.
Questions. Yeah.
The first question that I see here in the list of questions is, can you talk a little bit about error handling in Builder? You see, please give an example with builder pattern with a view different builder pattern, the return result of builder and error. In general, let's just talk about errors that can happen during building something.
Yeah, so the way I would approach it, the thing is now TypeState actually helps me to make impossible states impossible. And I guess this is the goal of Rust in general. And Rust has various ways to do so. One thing that you've seen is the builder pattern, yes, but also other things are option and result. Because option and result, both enums, urge you to deal with errors and to deal with undefined states, which is great, which is one of those things about Rust that I love so much, because if you adhere to certain principles, like never using unwrap, always dealing with your errors, you can write really, really, really safe code. And you write programs that don't have those typical ACEs like null pointer exceptions, undefined not a function, everything that you've seen in all the other programming languages. So this is why I love result and option for that. In that case, if I would have a build method where I have an undefined state because I have no workload, I would see if, if self.workload.isNone, that's a method on an option, I would return an error which is a self-defined construction error. This is what I would do here. And if I have one, I would unwrap it, I would put it in the worker, and I would give an OK, a result with the actual worker then. And this is also a totally valid pattern. And it's also really, really nice because the function signature, or the method signature, tells you that something might go wrong here by just having a result as a return type. And you as a developer need to work with it. You need to explicitly deal with it. The difference to the type-state pattern that I showed you is that with type-state, I'm preventing those situations up front, whereas with a result, I'm preventing them after the fact. So I might have results that are not like I want them to be, and then I need to work with them. So yeah.
Thank you. Thank you very much for the answer.
I hope this answers your questions, by the way.
Yeah. I guess if it doesn't answer the question, please let us know. I was just a little bit of distracted because my cat tried to eat the rest of my pasta. So I had to get rid of the cat now.
Show your cat. The chat says show your cat.
Cat Mary, she's down there. She will come up again because she smells my pasta. But let's go back to the more important stuff than just talking about my pasta here. The next question is one about macros. Is there any macro to automatically generate types for builder states?
This is a very good question.
Something like this.
Yeah, I don't know of any, actually. It wouldn't wonder me if there is anything, because usually you get crates with macros everywhere on Crates.io. So, but I don't know of any. So, but my approach is usually to try out things like they work under the hood. I also, when I teach error handling, for example, I never use anyhow. And this error, what we've seen with Elliot, I'm usually writing them on my own because you get a better feeling of how something is constructed. Not in production code, obviously. So there I'm using macros, but I don't know of a builder pattern that does it like that. It might be because builders usually tend to be very specific to the product they are creating. And if you looked at the thread builder or the command builder, which builds a child process, they have vastly different APIs. It's just that the pattern, like the implementation and the purpose behind them is similar, but they don't adhere to any convention, for example, which speaks again. If we say how well did those patterns hold up, it speaks a lot for those patterns, because to have a pattern that can be used in so many situations with so many styles, but has still the same pattern, and you recognize it, I think that's beautiful. So I as an API nerd, I loved it.
Okay, very interesting. Thank you very much. Thank you very much. Let me quickly go through the questions again. There were some details about which were relating to some lines of code. I'm not sure if we can cover that again. Somebody recognized some builder patterns from the clap crate, which is a very widely used one. Do you want to say something about that?
I haven't used clap too much, so I can't say anything about clap. But yeah, clap would be a perfect case for that, actually.
Yeah, absolutely. Yeah. So everything else is thanks and awesome talk and great approach and thank you and show me your cat. And I think
I've seen two questions here.
Yeah,
if that's okay for you.
Yeah, absolutely.
One is this: why do you need to clone the workload, build self workload clone? Yeah. So first, because I'm lazy, but and also maybe because I've used the wrong ownership in the build method. I always said that I took a mutable reference to self in build, but I should have taken an owned self, because then after build, workload self can go out of scope, which means that it can transfer ownership on the workload easy to the worker itself, and it doesn't need to be in the builder. So this was an error on my part, and I just realized the mutable signature, but not the other one exactly. And there was another question related to that, consumer versus non-consumer, move ownership versus using references. Okay, sorry, that's not a question, but this is related to that. Yeah. Okay.
Okay.
And I think.
Very nice. So now you need to make another book on using Rust patterns in production-grade projects. So Stefan, I think you can put that on your to-do list.
Gandhi just reminded me that I need to extend my ownership of rust-book.com. So, but yeah, I have a couple of topics that I want to talk about. Maybe, I don't know. I want to finish the one that I'm currently working on.
Awesome.
And
awesome.
then I usually say I'm never writing a book again, but I already said it 3 times. So
yeah. So, very good. Very good. So Stefan, thank you very much for the talk. Thank you to everybody who was watching. Of course, we will publish the recordings of our talks on YouTube. Might take us a few days, a few weeks. It depends on our personal workload, especially this part on Stefan's workload. So we will see, but it will definitely show up on YouTube. I'm very sure about that.
Might take a week. So
yeah, that's fine. I think that's perfectly fine. That's perfectly fine. So I think with that, we are through for today. What do you think, Stefan? Do we have anything else to announce?
I don't think so.
Good.
So
good.
I think we're all done. Yeah.
We are all set. So everybody, enjoy the rest of the day. Have a very beautiful evening. And just came in another question, which is not related to Rust, but to something
anyway,
completely different. Do you want to say something on it?
Any thoughts on Deno?
That on Discord.
Oh no, that's good. So if you still have the time, we can also chat on Discord. So I'm online if you want to hang out afterwards. I'm going to get something to eat, but I will answer all the questions that I get on Discord. My upcoming TypeScript cookbook. Thank you very much for the plug, so I don't have to. It will contain chapters on Deno, mostly how to get types for Deno and how to construct Deno projects. I love using Deno, so I use Deno a lot at work. We are using it in a scenario that is usually not how you would write Deno applications regularly. But it's very versatile, it's very flexible, it has fantastic APIs, and writing Deno is usually a joy. So I really love what they are doing on an API perspective and how JavaScript code should be or TypeScript code should be. I wish they were more popular, but they now announced that they have NPM compatible bindings, which is great. So you have lots of dependencies that you can use. And which should ease adoption quite a lot. And it's written in Rust, so it's super easy for me to contribute. And we've already, so the team that I'm working with already has done a contribution.
Yeah, nice.
Yeah,
nice.
Yeah, I can't remember which one again, but we have. I guess we've made one field public that wasn't public before. So I guess that was it. So
definitely useful. If you need it, it's perfect to have it. Yeah. Okay. I think with that, we should close it for today. Thank you very much. Enjoy the rest of the evening. See you next month at the Rust Linz Meetup. Goodbye, everybody. Thank you, Stefan, again. Goodbye. See you.
Bye-bye.
Bye.